Hello and welcome to the second devlog of the Casino Slot series. My name is Vladislav, and in this devlog I'm going to show you how are we making the animations for the symbols. The problem that we have here with animating symbols is that for example, we have 10 slots at the moment, and each slot may have, let's say, around 10 symbols per slot. So if you combine them together, that's like 100 symbols at minimum. If you want to show animation on each symbol, which is different from another, you understand that that's too many animations, and with the team that we have currently, it will take too much time. So what we decided to do is something a bit different than just animating every single symbol separately. For example, if we go to the Alchemist, one of the slots that we have, and let me show you if we catch something. As you can see, we got two symbols. These two are scatters and wild in the current slot machine, the Alchemist. So they're animating with a bit of light passing through, and or at least the illusion for light, and just some colors changing a bit. That's how we managed to do all the animations currently for all the slots, because as I said, like 100 slots, 100 symbols, or like if we have more slot machines, that's a lot. It's just a lot of work, and you have to take into account that if we have 10 symbols in one slot machine, and maybe we have a free spin in which the symbols change somehow, then we have to have even more animations. So that's, let's say, if the slot machine is with 10 symbols and the free spins have separate symbols from that, we should have 20 animations only for a single slot machine. And with the team that we have, we can't afford that because it will take too much time. So let me show you the actual shader that we're using here for this kind of animation. This is our shader. It's not that big, but it does the job perfectly. They're just some key components that I'm going to show you now. First thing, we're creating or just simulating a passing light. We're doing this with a gradient noise. If you're not familiar with PBR shader, I'm not very good at creating shaders by code, so this is a very useful tool that I'm using, and I'm going to link it in the description. It's included in Unity, but I find it more easy for me to use. We're starting with a time node, which is connected to a 1 minus node, and the only reason I'm connecting it to 1 minus is because, as you can see here, the animation is going from left to right, and if we just connect it straight to the multiply, you can see that it's going backwards. So the only reason I'm connecting the 1 minus node to the time node is to reverse the positioning or the movement. Also, we have some parameters here, which I like to put more often because it's easier when you're outside of the shader and you want to change some values, just tweak some stuff. It's very easy to pass the values from outside and work with this. Like you can use it from your script. That's mainly why you should use it actually. Then, after we have the gradient noise, we just remap it a bit so we lighten up the colors. Just again tweak it a bit as we like. Then the main stuff here are that we're inputting our texture we want to modify. In our example, we use this beautiful flower. We use it for one of our, this is one of our symbols. I think it was a scatter. Then we just go here, we're adding our remap to our texture by multiplying it. Also, if you notice here, after inputting the texture, I'm multiplying the RGBA with our alpha, which I'm not sure why, but it usually there's a bug, or I'm not sure if it's a bug, but if you don't multiply the RGBA with the alpha, usually the alpha is not included in the texture. So if we just pass the RGBA to the remap, the end result in the PBR master and in the preview, it won't be outputted as it won't include the alpha values. Or at least it bugs out sometimes, I'm not sure why. But that's the case. If that's the case, you can fix it like this. Just multiply the RGBA with alpha every time you need to be sure that your alpha is actually used. Also, just keep in mind, if you've never used PBR, that here in the preview window of each node, it's not always accurate. Like sometimes you say strange stuff maybe to what you're trying to do, like not the stuff that they're actually outputting. So keep that in mind and don't be worried if it just doesn't work in the preview, because it actually maybe it works. Next, what we're doing is actually separating each channel to a separate layer. And let me show you why I wanted to do this. If we have one channel mixer here and we just output our RGBA, you can see that image is the same. But the main thing about animating, or the way we are animating this, is exactly changing the RGBA. So this is the color scheme. And as you can see, when you change some of the stuff, the symbol just gets brighter or changes color. You know, you can tweak it as you like and you get very different results. That's exactly what our animation is doing. So not only we have the one texture for our animation, but we just change the colors and we get a completely different symbol, which is very cool because it gets the job done easier and with less code, and that's how we decided to use it. But the issue here with using a channel mixer is that we can't pass actual values from our parameters outside. And we actually want to do this because, again, if we have 100 symbols, we can't have 100 shaders here, and in which we're changing the channel mixer value, which will be insane. So what we want to do is have one shader and pass the values from outside. How do we split actual values instead of using channel mixer is that we have dot product. This node helps us do this. When we pass as a first value on the A side, we're passing our end image from the passing light. And with the second value, we're passing the color. And by color, I mean we just our parameter is just a vector tree, which includes 1, 0, 0, for example, for red. And we have for green, we have for blue as well. This separates the colors as we want, and then we just combine them so we can use them in the image. So this is exactly the same as maybe we're doing with the channel mixer, and if we pass this channel mixer like this, just inputting from the multiply. So this channel mixer is the same as this for. Let's delete it for now. And this is our end image after we have a way now to manipulate each cover separately from outside. And if we decide to change here some values, as you can see, uh, we're starting to see very different stuff in the combination, and not only. Now next, what we do here is, it's not required, but I just did it this way because I don't know, I like it and it works for now. We input again the same texture, which is, we're using it just from the same parameter actually, so no need to do a second parameter for the same texture if you're doing it this way. And just for a better effect, or at least that's how what I found that works for us, is the output from our combined texture. Um, we blend it with the normal texture. So it's not that much different, as you can see. It's just like a bit brighter because we use mode difference. You can change it to whatever you like if you want to use blend mode, but it's not required. As I said, you see, even only with the channel mixer, you can get very different results here. It's just a bit of another layer that gives us some more options. The only problem here for now is that we actually can't change the blending option from outside. At least I didn't make it to be changed from outside because the difference mode works for us very good. But maybe in the future I'm going to separate those every one of those nodes here, those modes, and make it that we can change the modes from outside. So next, what we have here is a custom function, which purpose is to show or hide the animation. Why we need this is because let's say we have the symbol on the screen, but the symbol is not caught. And the symbol uses always our material, which material is this shader. So we don't want to show the animation every time the symbol is on the screen, but we want to show the symbol. So that's exactly what we're doing. We pass from outside, we have a parameter to check if we have a line that's caught or if we don't have a winning combination. So how we do this is we just, as you can see, we have the input, which is a simple texture, our texture, which is not doing anything, which will be the base symbol that we're seeing on the screen. So we just want to output this. Like if nothing is happening, we don't need to output anything else. And if we have a winning combination, we want to output this, which is the animated version, which is all the passing light plus the channel mixer. And as you can see here, I'm not sure if you're familiar with custom functions, but if you don't be scared, it's nothing special, or at least what I've made, it's nothing special. The input, we have input which is boolean, which is true or false. We have two vectors. And then with this code, we just check if our boolean, if we set from outside that we want to show the animated version, we just check if it's true. And if we want to show the animated version, we will output the vector 4 from the animated symbol. And if it's not, we're going to output the normal symbol. That's all what we're doing. So our custom function then outputs the end symbol, the end result. And as you can see, the only thing that I'm doing differently here than just outputting everything is that we have one split for the alpha, so we can output the alpha as well. And that's it. Our symbol works. And if we go outside of the project, now if we want to see our shader in action, we just have to go to our materials, which are already created. Let me show you just some of the examples. And the first thing is that you can notice we have every one option here that we need to change the symbol colors or just show and hide the animation. Let me show you how it works. We just change this to square, and now in our preview, if as you can see, it's a normal image. So every time we have this material, if the animation is not started, it will be just a normal image. But when we start the animation, that's what I was talking about our custom function. You can see it's just working now. So every time we have a winning combination, we're just disabling and enabling if the animation should be shown. And the same, and this is from our shiny symbol, the shiny symbol. And that's how it's called, our shader. If we go to another flower, again, another symbol, as you can see, it's the same. We enable the animation and you can see it's completely different. That's how we're managing currently our animations without doing that much work, because there are a lot of stuff that needs to be done. And that was one of the solutions we came up with, just so we can make the work a bit easier. And it looks beautiful. I mean, I really like it, how it turns out. Well, that was it. Thank you for watching. If you have any questions, please ask, and see you next time.